Lecture 11.5, Double Integration. We start right out with an example. Consider the surface defined by f of x and y equals 4 minus x minus y. Find the volume under this surface where x is between 0 and 2 and y is between 0 and 1. We can sketch the graph by putting in the corners. Where x equals 0, y equals 0, f of xy equals 4. Where x equals 2, y equals 0, f of xy equals 2. Where x equals 0, y equals 1, f of xy equals 3. And where x equals 2, y equals 1, f of xy equals 1. Remember, f of xy is the same as z. Now we draw our shape. We could hold x constant and take a slice through the shape. The area of the slice is given by the integral from 0 to 1 of 4 minus x minus y dy. The volume of the slice is area times thickness, that is, area times dx. We can add up the volumes of the slices by the integral from 0 to 2 of the integral from 0 to 1 of 4 minus x minus y dy dx. We do the inside integral first. So we have the integral from 0 to 2 of 4y minus xy minus 1/2 y squared evaluated from 0 to 1. Now when we did this inside integral, x was considered a constant. We evaluate, and now we do the outside integral. Taking the antiderivative, we have 4x minus 1/2 x squared minus 1/2 x from 0 to 2, or 8 minus 2 minus 1, or 5. The base does not have to be a rectangle. Here's another example. F of xy equals 3 minus x minus y with triangular base between the x-axis, x equals 1, and y equals x. Looking straight down at the base, it looks like this. We use a vertical slice, and we get the integral from 0 to 1 of the integral from 0 to x, 3 minus x minus y dy dx. This inside integral is finding the area of the slice, and the slice goes from 0 to x because the equation of this line is y equals x. And then we add up all the areas times dx, which makes it all the volumes from 0 to 1. So we have the area of the slice, the thickness of the slice, and we add all the slices from 0 to 1. We evaluate the inside integral, plug in our limits of integration, and then we'll evaluate the outside integral. And we get 1. On the TI-89, it looks like this. Notice we have nested integrals. We still get 1. And our red pie tells us that this is the end of this lecture. This is the last regular lecture, although there are some bonus lectures in this series.